Hello everybody, Brad the Guitologist here. Enjoy the video.
He's just so cute, isn't he?
Hey, what's up dudes and dudettes? Brad the Guitologist here. Time to open a box and fix some stuff. If that sounds interesting, stick around. Okay, so let's open this box and see what we've gotten ourselves into this time. Okay, that looks like a schematic and possibly a note. Alright, and some tubes. We've got some tubes. Looks like a 6v6 push-pull amplifier possibly. With a, ooh. Oh, this tube has taken a whack. Somehow. Actually, that was just the... I think we're probably okay. Let's see what we have here. Okay, this is a Grommes custom model 50 PG3. Let's see. My former text notes. Powered up, hums, AC on DC. Not sure what that means. P.S. Electrolytics require replacement. Two-prong power cord replaced. Replace a C1A and C1B and R29. Let's see what it is. Let's see what those are. Or could that be C14? No, it says C1A, but there's no C1A I don't see on here. Anyway, we'll figure it out. Let's see. Tested some tubes here. And it looks like they tested okay on this person's tester. And that means very little. Also, I believe he replaced the selector with a regular pot, volume pot. It already works as a volume gain combination, depending which volume is cranked, but needs to be smoother. Really like the precise watch timer conversion and result. Can you make the Grommes sound like that? Well, that was a completely different animal. That was like a 1-watt amp. So, you know, probably not, but we might be able to mimic that in some ways, yes. Okay, so here is the schematic, and here's what we're working on. So yeah, this should be a fun one. This should be a good sounding amplifier. Let's go ahead and pull it out of here. Oh yeah, this is going to be cool. This thing's going to be cool. I can already tell this is going to be a badass amp when we're done with this, folks. Okay, so he did replace this selector already with a pot. So we'll have to see what he did there. We also have a 1/4-inch jack already installed, so you know, some of the work has already been done for us here. So that's cool, and that's cool. And that's probably what I would have done as well. Change that into a master volume or something of that sort. That's still okay. That's still the power off. We have a bass and a treble. Pretty simple. This is a pretty simple amp. This one's going to be yeah, this is going to be a badass amp. Here's what we're going to do. I'm going to basically look at the schematic. We'll look at what's been done so far. Look and see if there's anything else that we may want to do. We'll look and see if there's things that we may need to do, such as, like I said, replace those capacitors. Alright, here we are inside of this Gromme, and this thing seems to be you know, extensively redone. We have all of the electrolytic capacitors. As you can see there, they've been detached. And we have some new ones here, a couple of bigger ones. We've got another one right there, which I presume is a bypass capacitor. We've got all of these caps, these yellow ones here. Those are all replacements. That domino is still old, that mica mold. We have a couple of these disc capacitors have remained. I'm sure they're in the tone circuit, as is that one probably. Let's see what else. Got a couple of these white ones over here. There's 3 of these that seem to have been replaced. Now some of this stuff that's in here, like for instance this, I would have done slightly different. This isn't this isn't bad work. Here's another, on the whole, but there's some things I would have definitely done differently, like the way that this is kind of in here, I might have done slightly different. That's not the worst though. This can kind of move around a little bit if it gets jostled, and then you've got this exposed, and it could lean up against something else if it really took a whack, so those should be secured a little better, or at least should be shrink tubed where you have anything that's exposed like that moves around. Now if something's really solid, it's not a big deal. You don't have to shrink tube every single thing, but if you got something like this that's kind of long and can move around, it usually is best to try to shrink tube on open connections like that. Also this one here, as you can see, it is shrink tubed, but it's just kind of flopping, it's not very secure. Same with this one, it's not very secure. And as a matter of fact, I probably would have just put these at the site rather than running these leads. Why not just put them at the site and then ground them? It would be way more secure that way than rather than running these long leads like this. I'm not sure if this is for bias or what, but if they've got a couple of resistors here in series, so I would presume that's an effort to bias the amp, but I don't know. Well, maybe not. No, because that's a dropping resistor, I'm sure. Going to there. Let's see. Yep. And then it eventually comes out to this one. Okay, so that's a dropping resistance. I don't know. There's a few things about it that I would probably have done differently, I'm sure. We have a couple of capacitors are also over here that seem to have been left in inexplicably. So these were changed over here, but these were left. Maybe they're good, maybe not, I don't really know, but I don't see any reason really to leave these if you were going to replace these over here. But we'll see. It does look like there's been some modifications. I don't know what necessarily all this stuff is about. This is a bit iffy here, the way that this is kind of wired. I don't know. It's just one of those things. Really, this resistor here, this is probably meant to be the grid stopper into the first stage, and it looks, it should be over here really on the socket, ideally. So we may reverse that, keep the shielded wire, but do something different with it. But just little things like this, I think I would have done differently, and we probably will change. But first thing I want to do is dial this on the Variac and see what it's doing or not doing as it sits. Okay, so I have this plugged into a speaker here on the desk. It's on 8 ohms, and it's selectable, and this can probably stay. This is probably similar to what I would have done. We do have 1, 2, 3 inputs on the rear right here that are not being used. They're all RCA jacks, and they've been completely removed from the circuit, as has this switch right here. So these are opportunities we could do something else if we wanted to without having to drill holes. This is an opportunity to do something different without having to use a switch. So these are things that we can think about. Let's see what else we have a couple of auxiliary plugs here on the rear that have been removed as well. Might have been nice to leave one of those just in case you wanted to plug in like a pedal board or something. It could have you could have just done that off the back of your amp. Sometimes that's helpful, but you know, since they're removed, it really doesn't matter. The three-prong cord has been replaced, but is not particularly secure. I'm going to put and I might as well go ahead and do that right now. I will leave that as is. It's got a grommet in it, and it's probably fine. You can just push it in. If you look here, you can push this thing in. You can't pull it out really because it's got a knot tied in it, which is fine. But you can push it in and cause some havoc that way. So let's do something about that. Usually, what I like to do for that is just to put some put something in the way to keep it from doing that. Is put a zip tie on. Now you can't do that.
So now what happens?
Okay, so there's that done. Let's go ahead and dial it up, like I said, on the Variac here, and we'll see what it's doing or not doing. Thought I was hearing some sound there for a second, but that's an airplane. Okay, we got our customary halfway stopping point here. I like to stop here because that's when my Variac starts to give me readings on the current. And I might change that because I think there's a mod I can do to take this all the way to 0, which might be the subject of another video. But for now, I usually like to stop at about halfway just to see how things are going. And we're only at 19.5 watts of power consumption and 320 milliamps. So no big deal right there. No sound so far. I would have expected some sound. Let's go up to about 72. But well, let's go up to about 80 volts. And we're at 32 watts of power consumption, 430 milliamps. And still nothing. Why do we have nothing on the output? That is interesting. Okay, the 8 ohm tap, that is hooked up. And I hear absolutely nothing out of this thing. Nothing at all. So why is that? Is there something I'm missing? What am I missing? Maybe I just gotta dial it up more to get anything out of it, but I wouldn't have expected that, to get nothing. The tubes are warm, so something's going on. I don't see any filament glow. I don't see any filament glow on any of these. I mean, that doesn't always... Okay, I do see filament. Yeah, I see filaments. Okay. I see it on the power tubes, but nothing else. Is there filament glowing? It's kind of hard to tell. I've got some bright lights in here, so it's really a bit hard to tell. Tell you what, let's go ahead and dial it up just a little more and just see what it does. I mean, but so far, nothing. I would have expected something by now, but it's dead. Let's see if we have any rectification going on. Let's see if we've got anything else, anything on the other side of the rectifier. The rectifier's hot. Let's see if we've got anything on this though. For instance, right here. Yep, 286 volts right there. $292 right there. So that will be the first. This will be the first node here. 310 volts. Okay. So we do have some DC, but why am I getting nothing at all when I'm 96 volts in? Is there a short somewhere? I don't think his notes said anything about having no sound at all, or did it? Hang on. Maybe I just missed that. Well, this could be a fun one. It's always fun troubleshooting amps when there's no sound. And again, I mean, just starting from scratch. I know I've got DC voltage, so my rectifier's good. I know my power transformer's good because I have DC voltage. I can see the glow of the output tubes, so I'm assuming all of my filament wires are probably fine. So what else is there beyond that? Something must be just getting grounded out. Very interesting. Very interesting indeed. What am I missing here? Okay, so we've got signal that should come in off of this thing, right? So that's the ground connection right there, that big mess. Okay, see, so this one comes over here to pin 7 of this tube. Alright, I think it's time to do a little bit of signal tracing and just see what's going on. I might also check the voltages on this V1. Actually, let's go ahead and do that. Let's go ahead and check voltages on this V1 tube right here. We have, alright, this plate resistor right here coming in to V1, so this should be one of them. And we have 275 volts right there. 275 volts on that plate. On the other one, we have 275 volts, so we've got voltage there. Might even be quicker to strip everything back to like the just the windings, you know, leave the transformer windings and stuff intact, like those wires, you know, leave that winding going into the rectifier and all that stuff, and just redoing virtually everything else. This might be one of those times that ends up happening. Let's check the voltages on the output tubes plates. 1, 2, 3. Ooh, man, look at that. See that exposed wire right there? That thing has just been burned to a crisp. See that? See that right there? That wire that's kind of been burned. Yeah, 307 volts on that plate. Okay, and then this one over here, that should be the other one. 303 volts right there. You know, if we're getting voltage at the plates, then the primary of the output transformer should be okay. I'm worried that the secondary might not be okay. Let's kill the voltage coming in, and we'll check the output. Let's unplug this so we're not getting anything there. And again, we do have this selector. I'm just wondering whether or not maybe, because you see the way they've got this wire. See this wire right here? Okay, it's connected there. Then it's going through the tiniest little hole right there, and and it's bare metal. So I'm wondering whether or not that thing is grounding itself out on that. And if it is, that would explain why we're getting nothing. Okay, but yeah, see what I mean? There's just the tiniest little hole that was left here, and they used that to bring this wire out. So what I'm going to do here instead is this. I'm just going to undo this blade. All right, and now we can just run some clips, some gator clips instead.
So now what did you do after that?
Okay. So I've just hooked this up directly. I've got my gator clip, one of them on the 8 ohm tap, and I've got the other one to ground. So let's see if we get anything now when we dial it up. Yeah, see? I should be, when I decouple that, I should be getting something at the input. But I'm getting absolutely nothing. Could it be just a completely dead tube? I guess it could be a completely dead tube, but I wouldn't have. I mean, usually a tube doesn't go just completely dead. But I'll grab a tube and cycle one in and we'll see. Maybe that's the case. Okay, so as usual, I have a probe and there is a capacitor inside of here that will block any DC. I'm going to stick this to the tip of a cord, and this cord is running over to my bench amplifier over there. So we'll turn that bench amplifier on. We also need another cable to go from ground to ground. Right. And I just need to get this somewhere where it can't short against anything. Set that down. Alright, ready to probe. We should be getting a signal here at the input. Let's test that. So there's that signal. Let's turn it down a little bit. Alright. So there's our signal at the jack. Now let's follow that down here. Oh, we lose the signal right there. What? Oh, okay, we've got it. That's odd, though. Why do we not have anything right there? Oh, that's the insulator. Duh. Okay. So we've got signal there. What about coming off of the plate? Got nothing. Got absolutely nothing coming off the plate of V1. So maybe the trip, if you'll recall, whenever I opened up the box, that V1 tube was kind of cocked sideways. So I don't know, maybe there's something up with that. But we've got absolutely no signal coming out of V1. Nothing at all. So that first stage is dead. It looks like maybe there's a little slightest hint of a hairline crack right there, and maybe this thing has gone to air, but it's kind of hard to tell. I don't know. At any rate, we know that it's dead, and it could be just a matter of the filament having been severed. So let's replace that tube and see what we get after that. I've still got absolutely nothing. What's going on? What's the deal, though? So I don't think it was the tube. Let's go ahead and let's put our original tube back in, so I'm not screwing around. There's something is amiss, though. If I'm not getting any conduction at all between the signal from the signal of the grid to plate, if I'm not getting anything, this tube is not conducting. It's doing nothing. It's dead. So why is it dead? I think we already established that we have voltage to that tube. So what are the other causes, potential causes of death on a tube like that? One of them is no filament voltage. I'm trying to look at the filament wires here. And yes, Okay, this wire looks a little suspicious. Okay, so there's the pin 9 right there. See that green wire? Okay, that green wire is running over to this point right here, and it looks to me like that might be a cold solder joint right there. Is it? Or yeah, it is. Look at that. See that? See that filament wire right there? Look at that moving around. See that? It's not even connected, but just barely. Just barely on there. See? See what I mean? Okay, so let's put some solder to that for sure. Now that might not be the only problem, but it's definitely a problem. Can't leave it like that. And that's the problem, man, when you get, it's almost better to get some of these projects when they're virgin, you know, I mean, I would almost prefer to have one that hasn't been screwed with at all, because you know, a good eight or nine times out of 10, you're just going to run into problems that the previous guy kind of created. And you know, like I said, I don't wish any offense on anyone, but that right there is probably something. If he didn't create it, then that's been there since the factory. And if that's a factory thing, then you know, this thing might have always been intermittent. And see, once again, none of these are twisted wires, you know. So let's hit it with some solder, shall we? Get it even better than that. Just make sure we thoroughly heat it. Okay, now that's a connection.
Where old-fashioned romance meets modern-day technology.
I didn't see any glow on any of the preamp tubes. I saw glow on the output tubes, but not the preamp tubes. So maybe there's another loose connection that I'm missing as well. Let's go back a little further over here and see if I can find something else. Look at this. See all that black right there? And you see that bare wire right there? You see that? I think that wire right there got up against something. It got up against the wrong thing, and sparks flew at some point. But you can certainly see it there. Something burned. Maybe it was the original dropping resistor that was in this spot. Maybe that resistor might have gotten hot, burned this, and burned, made that burn mark. Maybe that happened all at once. Maybe it happened over time. But it definitely has been burned right there. Let's tell you what. Let's fire it up now and see if that fixed it. That filament wire. Now we're getting something. Now we're getting noise. Well, that was fun, wasn't it? First thing we do is have to troubleshoot something. Okay, so I'm curious, naturally, what this thing sounds like as is. So let's test it as is. Now, of course, you're going to have to use your imagination a little bit, because I've got this thing. I'm just using the little speaker out on the desk. There's no cabinet. It's just a speaker exposed on the desk, which is my usual MO. If you guys follow my channel, you know how I usually work it. Some of you guys who do amp building and stuff probably scoff at it, but there it is. You know, it is what it is. That's actually, I mean, that's not the worst thing in the world. I've heard much worse. That's not a bad tone, really. Smoother. Now that could mean a lot of things. Smoother. That is the directive I've been given. Make it smoother. Uh-oh. See that? You hear that? Okay, there's a bad ground. So something over here is not grounded properly. So one of these connections is bad, either this, maybe one of these. I think the thing to do here would be to reflow all of this solder, all these connections, and make sure they're good. But it could be a case also of one of these capacitors going bad. Let's go ahead and kill it, and we'll reflow some solder first. But yeah, you know what I was saying is, and we'll go ahead and do this work. But what I was saying is, I probably need to consult with my notes where I had corresponded with this customer and see if he gave any other indication of what he wants done, because from what I can hear, at least on this, with my Telecaster and this speaker set up on this bench, I mean, to me it sounds pretty rocking. And I would imagine, usually, you know, I've done so many of these like this that I can usually kind of extrapolate what an amp is going to sound like when I put it on a cabinet based on what it sounds like with this, you know, speaker out here on the bench. I know it sounds stupid, it sounds corny, but usually it works out pretty well. I can usually extrapolate fairly well what it's going to sound like in most, you know, cabinets. So, but based on that, I mean, it sounds great to me. So I don't know, so far at least. But let's look and see what else he had to say about this. Okay, so let me read to you what this gentleman said in his email. He said, the amp pots selector doesn't select anything at all. It's just another volume control. Volume, bass, treble. It doesn't sound bad, but I can't get the tight, smooth overdrive out of it that I hear coming out of the amps you so graciously share with all of us. I don't think my former tech did anything to it, and if he did, maybe he just replaced old caps. I was hoping for a mod that would make the selector and volume work as a volume and a master, so that I could dial desired overdrive and still play in my living room enjoying the juicy tones while not driving my very tolerant wife crazy. Well, it already has that. You've got a volume and a master volume. That's, you know, this volume control here, this one, if you're wanting creamy distortion, that's the one you want to crank pretty much all the way up to 10. And this second one right here, you can kind of keep that down around 1 or something for living room jamming. And, you know, I mean, I don't know if it came through very well in the demo I just did, but it sounded pretty good to me. The only thing I would recommend doing, there's a 0.47 microfarad capacitor right here. I mean, I could do some things to try to smooth this, to get a little bit of a creamier distortion and maybe smooth it out, you know, quote unquote. Here's a 0.47 microfarad capacitor. I could up that value just a hair. That's a bypass capacitor. There's a 0.1 microfarad capacitor coming out of that stage to the first volume control. It looks like there used to be a rumble filter on this. Rumble filter. So when you engaged it, it would give you some feedback. And that's been removed, I guess. I guess it was this switch back here, this mic. It was probably that one right there, that mic phono switch, I'm guessing. So that's gone. I could change these, this first stage's 100K plate resistor to something more like a 220. And that might punch through a little bit more, more gain out of this stage. I could slightly up this value as well to make it a little creamier, maybe like a 0.015 capacitor, possibly. That would shift the bass cutoff, so it would get a little bit more low end through, and that would also increase the gain slightly. I could try a 0.22 capacitor as well, and that would increase the gain and the bass cutoff. So those three changes right there could just be the magic ticket you're looking for. But like I said, this thing does already have, you know, in place of this 3.3 meg resistor, it looks like they have substituted this potentiometer. And this, of course, this switch a little further downstream is no longer here. It just goes into that stage, I believe. But there's a volume control here. What is this? This is a, is that a 50K? Or is it a 500K? What does that say? Tap at, okay, the tap is at 50K. And what's this? What's this crap? Loudness out. I don't see any kind of other switch. Do you? Did you see any other switches? I didn't see any other switches, so I don't know what that could be. I will say that the bass and treble controls seem to be fine to me. I mean, again, I'm just using a Telecaster, but they seem okay to me. Smoother is a very subjective term. Any of these terms, you know, to describe how an amp behaves is always going to be somewhat subjective here. So I'm just going by what I'm hearing. You want it to be smoother, but you want it to break up. You want more crunch. Let me continue reading. Also, since it only has bass and treble, there's something missing. Maybe those two pots are choked by caps resistors. Oh, okay, so he's saying, you know, he thinks maybe there's something going on, like a tone sucking network or something. But I don't know. Let's look at this a little closer. Okay, so here's our controls. I mean, look at this. We have a this is a fairly sophisticated amp. I mean, this has got a it's got a cathode follower in front of these tone controls. So it's this is very Marshall-esque, you know, kind of already. I wouldn't call this anything that would suck any kind of tone. It looks fairly standard. I mean, it's kind of jumbled up the way it's notated. But okay, so it's filtering off 250 microfarads, so that's picofarad, 250 picofarad into this control, and that's fairly standard for a tone control, for a treble. Now that's 1.5 meg, so that's a pretty large value actually for a tone control, but okay. Okay, so what's happening here is the stuff that's filtered off from this line is getting bypassed through. So the more you turn this knob, the more of this you're allowing through. But if you increase resistance between this point and this point, then none of this that's filtered off to here is going to get through. So, okay, so that's how they've got that wired. Alright, this is passing lows into this control. I just don't see any evidence really here that there's what I would refer to as a tone sucking network. We've got a 1,000 picofarad, basically a bright cap just kind of going around this. So the more you turn down this control, it will go ahead and pass anything above a certain frequency through. And then this will kind of be like your fixed mid control is 22K. That could be changed, I suppose. If you don't like the style of crunch that you have now, that right there could be changed, or that could be made switchable possibly. I could possibly use this switch on the back to change that, the value of that resistor, and that could maybe give you some flexibility. So yeah, like I said, let me put my thinking cap on and we'll see what we can do here. We'll see what we can come up with to try to make this smoother and able to, you know, get juicy tones while not driving your tolerant wife crazy. So that's the directive I've been given. He goes on to say, I'm not looking for a Dumble or a train wreck, and I'm not a Marshall guy either, but maybe it's not that difficult to tweak it and make it sound a bit better. You know, I don't know. I'm a bit confused on the directives that I've been given, but I'm going to try to roll with it. So the master volume control is after the second stage. So we've got a volume control after the first stage, and then it goes through one more stage, and then the master volume. Well, that's not really all that useful, to be honest, to have only one stage between volumes. So we're going to take this volume, the master volume, and move it right before the phase inverter. Yeah, so basically it looks like it's after this second stage. So we've got this first stage and then a volume control, and then we have a second stage and another volume control before this third stage. But what I'm proposing, yeah, see, this is the volume control as it exists now. There, that is. That's the master volume, only after the second stage. So we're going to take this master volume, delete it from this point, and move it way over here, right in front of the phase inverter. So we're going to move it right here. I did go ahead and tighten up this this capacitor can by turning these tabs. So I twisted those a little further, all three of them, and flowed all of the solder on that. So that should be, it is actually a lot tighter now. That capacitor's much tighter. So hopefully that won't, you won't get that popping noise anymore where that ground is coming undone. Now I did talk about changing possibly this capacitor right here coming out of this first stage, which is a 0.01. I may leave that for the time being, but again, I am definitely going to shrink tube over this right here if we do leave it. But I may also possibly think about making that an even lower value, something on the order of like a Marshall 2204 has in that position, which is a 0.002. Now I did also talk about possibly changing this 100K resistor to a 220K, but that's when I was, you know, thinking in terms of, okay, he wants this thing to really break up with a singy overdrive lead at very low volume, so we're going to have to do everything we can to pump as much gain as we can early on. So that still something I might do, but at this point what I want to do first is see what these other changes are going to do. For instance, that moving that master volume later is going to have a big impact, so I think let's do that first, really. I've already changed this to a 0.68 microfarad capacitor, so, and that's in lieu of this what is this, a 0.47. So we've gone from a 0.47 to a 0.68. So that should help a little bit as well. Also, removing that 220K snubber resistor and this resistor right here to ground, which just seems unnecessary to me. It seems like an afterthought. It seems like something tacked in to possibly stabilize this. So what I'm going to do instead is come off of this with like a 100K resistor into this, so we'll still have 100K or so in line. I'm going to omit these two and see where that gets us. And also, while I'm over here anyway removing stuff, I'm going to clean this up. And we got solder blobs, and we had this ground wire that was kind of frayed out and going every which way, so I'm going to try to clean some of this up. Just want to add a little bit of solder to this ground. Not enough where we melt these leads together, but I want to add some. Just keep this from fraying out like it was. Okay, so that's just a little bit cleaner than it was. The other thing I don't like is that these these ends really aren't shrink tubed either. So you've got stray little bits of wire there that are kind of dangerously close to your actual lead. So I'm gonna put some shrink tube on this too. Okay. Alright, so there are those wires redone. Let's go ahead and move that master volume on down past the tone controls. And man, this thing should be about ready to go. I mean, besides the other little, you know, reliability things we need to change, I mean, it should pretty much be there at that point. Alright, so I've removed the leads from this volume control that were going here to this tube, and I've removed basically everything. So what I'm going to do is come from this stage right here, this point, over to here with a snubber resistor, and this is 100K. So that'll get us into this stage, and I'm also going to need a ground reference from there. So those are good. This is the wire leading into the phase inverter right there. So we need to remove that and go through the pot instead. We have moved this volume control further down the stream to right here before this stage. So let's see what this does now. Let's see if it squeals at us. Okay, that's a lot of gain, and this thing is going into oscillation at the top of the range on this. And I think well, basically what it is, as I have too much impedance on that stage. There's too much between those 1.5 meg resistors here and this one was this 500K resistor. Those combined is just way too much impedance into that next stage. Yeah, see, it's just kind of going into oscillation. So we got to do something about that. And what I might do is make this into a post-phase inverter master volume. That should solve that problem. So we'll just put that blue wire back where we found it and do something else with the master. Okay, I've skipped ahead a little bit on this thing because this video is running on a bit long. And as you can see here, what I've done is changed all of these capacitors that were in here, and I've put all discrete capacitors. I got rid of those nasty things they had over here that were flopping around. Got rid of a couple of these also, the two power capacitors. This other one here is a bypass cap, so it's lower voltage, not quite as critical. So just going to continue to use the one that's there because it does still work. But replaced all these power capacitors, and now the next thing I'm going to do is replace the tone stack. I'm going to take all of this stuff out completely, and what we're going to do in its place is actually steal the we'll steal the tone stack from a Princeton. So we're going to do something sort of like this, and it's going to run into our master volume also. And I think what the Princeton tone stack might accomplish for us is to maybe get this thing in more of the range of what the guy's talking about when he says smoother. So we're going to remove all of this stuff. This is our current tone stack, and as you can see, we have a 1.5 meg and a 1.5 meg. So this is a lot of ground reference right here. This is a lot of impedance into this next stage, and if we try to put a 1 meg on top of that volume pot, that's not going to work at all. So we're just going to replace all of this with that Princeton tone stack and see how that goes. I think it's going to be a little bit better. Okay, so I have replaced this tone stack with a Fender Princeton style tone stack, and it sounds very good. The only problem is it is also fairly noisy. So I've kind of been poking around and kind of looking at things that we can do to try to mitigate some of the noise. I twisted the filament wires running from V2 over to V1, and I'm going to go ahead and twist the rest of them as well. They're not twisted at all. You can see they're just angled and really running all over the place. And then you got the light there, and the leads for that are kind of running all over the place. This does have a center tap, and it's tied to the cathode over here. It's tied to the cathode of the output. It's this wire right here. But I'm going to try actually disconnecting that, I think, and doing a virtual center tap, because sometimes a virtual center tap is even quieter than an actual center tap. I know it's weird, but that actually does sometimes occur. So I'm going to see if that might quiet it down a little bit. Also, that it just looks in general like the grounding scheme is not really great. So I'm kind of reworking that. I had this ground wire here was running over to the grounds for the inputs, and it's just, I don't know, the grounding scheme is just kind of all screwed up. I've got okay, the first stage cathode is grounded over to this point. This second stage cathode is grounded to this point, but I've got the inputs for both those stages grounded over here. So I might rework that. I've got, again, I had this one that was connected over here, and that's for the grounding for all the rest of it. So basically you got power stuff and all the grounding kind of just smudged together, and then you've got a loop going on. It's just, I don't know. There's just crap kind of everywhere here, and I need to go through and sort of rework it. I did go ahead and replace this 100 microfarad capacitor here, which was the last one that we had remaining here. So I removed that and replaced it. So all the caps are now replaced completely, so that should be good to go. But again, we've just got hum whenever we crank this thing up, you know, past anywhere past like you know, 2 or 3 or something on the first control. So we go through it, see what's going on, see if we can't get the noise down. Okay, so I've wound the rest of the filament wires. It definitely looks a lot less messy in here, but how's it gonna sound? I don't know. It sometimes this helps, sometimes it doesn't really help much at all. I think the main thing about this amplifier that we have going against us is the fact that we have two transformers that are very, very close together, and this is a big no-no. If you were building this amp from scratch, really you don't ever want your power transformer and your output transformer this close, because what happens is you get flux from these transformers. That is, you get magnetic lines of force, and these lines of force extend out beyond the exterior of the transformer, and they actually can induce noise in adjacent transformers. So this is a big no-no. If this was being built from scratch, this output transformer really needs to be at the entire opposite end, or at least, you know, over here somewhere where it's kind of away from the power transformer, not right up next to it. So not the best design in the world as far as that goes. We're going to try to do our best here. Whenever you turn this thing on, even if you have it all the way down, you can physically feel the kind of 60 cycle hum that's going on. So I don't know if this is something that we're going to be able to fix. We're going to do our best, and I'm also going to tighten up these bolts on the power transformer as tight as I can possibly get them, and hope that helps a little bit too. But you know, I think we're just butting up against the limitations of the original design here, and at some point it's just going to have to be good enough. I don't think we're going to be able to minimize the noise much more than this. I have clipped the center tap here, and I'm going to test it with it clipped. Then I'm going to experiment with a virtual center tap, and then we'll just sort of go from there and see if that reduces the noise at all. Okay, I know you're probably dying to hear what I'm talking about as far as the noise goes, so we'll go ahead and fire it up, and I'll show you. Actually getting a lot of noise on this, for some reason, out of this that's interesting. Let me kill this for a second. Let me spray this out. That was odd right there. That hasn't happened yet. But it seemed like the this pot's wanting to be noisy now for some reason. See, I can move that pot around, and it's getting noisy. But you can hear that noise. But the thing is that, whoa, if I turn it all the way down, I can actually hear it just physically if I put my ear up down here. So it's actually, it's not terrible, but it, you know, it's still there. Yeah, this one's doing it too. Actually, that might be the one. That might be the one we replace right there. That's a bad pot. Look at that. Yeah, that's a bad pot. Let's replace that pot. That's not one that I put in. That's one that was put in by the previous tech. Okay, the main secondary center tap, which is this wire right here, was being ground over here, which is where the cap can was originally. Since we put discrete caps in here, I went ahead and just removed that secondary center tap ground and grounded it over here where the first node is being grounded, and it has quieted it down considerably. The only problem is now, for whatever reason, when I turn this up, it's going into oscillation at the top of the range. So we still have some noise that's being induced somewhere. We may be maybe pumping through a little bit too much gain, because this is a pretty high gain amplifier, really. Even with 12 AU7s in this, this thing is pretty smoking. And that's another thing. I did change the all three of the preamp tubes to 12 AU7s, trying to tame down the gain just slightly on this thing, and that did do what I predicted it would do. The only problem is now, again, we're going into this oscillation at the top. We'll look and see what we've got going here, but we're getting close. That actually quieted this thing down considerably. It's not even remotely the same as far as noise. Okay, guys, I've skipped way ahead here, and I'm going to try to go over all the changes that have been done so far. I've got one more little change I think I'm going to do, but it's pretty much done. As you can see here, there's a switch on the back for on and off now, because I had to replace this pot. I replaced it with a 50K, so now there's a 50K pot instead of a 1 meg pot. So big difference on the stage with master volume. So that's the master volume right there. So I'm going to start at the beginning here. We'll kind of go through it. Change the 1 meg resistor, grid leak resistor here, to a 470K. Coming on down here, as you can see, there's just a lot of changes. Of course, you guys know all about the power rail stuff, so all that's no surprise. And none of it's really changed. But we come into the first stage, shielded wires. We come out of that with a 0.01 capacitor right here, and of course I shrunk tube that. I'm going to a 100K resistor into this pot right here, which is a 1 meg. It comes out of this 1 meg. That is our gain pot, by the way. Comes out of that and goes to our second stage, which is biased with a 1.5K resistor and a 0.47 microfarad bypass capacitor. The first stage, by the way, is biased with a 0.68K and a 27, I believe. No, 22K. Or excuse me, a 2.2K resistor. Coming out of that, we go to another 0.01 microfarad coupling capacitor to the next stage. And pretty much everything over here has been completely changed. I changed some of the plate resistors. I changed this plate resistor. I changed that plate resistor on this stage. The grid leak resistor is now a 150K grid leak resistor. This one here. Okay, comes out of that stage, goes here. There was a 0.05 capacitor that came off of that and over here to one of these terminals, and I got rid of that, and we're just going straight into our tone stack from there. Of course, the tone stack is a Fender Princeton style tone stack. And it's pretty much exactly to a Princeton schematic, so no need to continue with that. But of course we do have a 50K pot here instead of the 1 meg that the Princeton calls for. That's just because we have a shit ton of gain and we're trying to tame things down. So 50K is close to the top of the range where this thing will start going into oscillation if you crank everything all the way up. This thing is so hot rodded it will start to go into oscillation, so you don't want to do that. This is and I've left it that way so that you can get to the very top of the range. You know, I'm not making it idiot proof this time. A lot of times I'll make my amps idiot proof, so you can't. There's no possible way to, you know, make one of them go into oscillation or something like that unless you just go in and modify it. But in this one's case, what I have decided to do is leave it that way because you can get some really interesting tones just up on the threshold of oscillation that, you know, you might want at some point. Someone may want that sort of tone, like if they're doing a recording for a track or something, so I've left it that way. But anyway, it comes out of that into a 100K resistor for the grid stopper into this next stage, and that is the phase inverter. Out of the phase inverter, I've changed the coupling capacitors out of the phase inverter. They were 0.02 coupling capacitors, and I've changed those to 0.1 coupling capacitors, and that's going to the output from there. And pretty much all these resistors on this section were pretty much left. Those I left okay. Those are on the power rail. The biggest thing I did really to stamp down the noise was to move that center tap over here. That was a huge difference in stamping out noise. We were getting some major problems with ground loop when we had it tied over to here. So if you have one of these, you need to move that. One other thing I want to point out is that, you know, you remember when I pointed out the fact that the transformers were so close together on this thing, that they're right next to each other, in fact. Well, I don't know if this is an earlier one or a later one or what the deal is, but you can see here, it wasn't always like that with this model. This one shows the transformer being way the hell over here where I suggested it should have been put to begin with. And then you have your power tubes here in the middle. Or these might be the power tubes here, and that, yeah, that's probably, those are the power tubes, I'm sure, and then that's the rectifier. So a different layout, and really probably a better one in terms of noise. But this one is pretty much, I've gotten this thing about as dead quiet as you're probably going to get it. As you can see, I have twisted all of the filament wires. That's these red and black ones here, and they are elevated up and coming down onto the sockets because there's really nowhere else to go with them, where they're going to be out of the way of everything. Twisted the lamp filament wires there. Changed changed these to match. They were green before. But I pretty much have it all cleaned up. It's looking a hell of a lot better. It's sounding a shit ton better. It sounds awesome, actually. Can't wait to do a demo here. But one more thing I am going to do. I'm going to put. I'm going to use this switch back here, the one that's not being used currently, that was left in before. I am going to make that a switchable feedback control, so you'll be able to reach back around, and if you want to stamp out noise or something like that, you want it just to be a little more tame, you'll be able to reach back here and switch the to a different feedback resistor, negative feedback, and that will give you some flexibility there as far as that goes. And if you don't want this thing to really scream, you can do that and get a lot tamer cleans out of the thing. So anyway, that is pretty much it. We're going to put the faceplate back on it. It's not on there right now, and I think we're just about ready to go.
How'd the date end?
Okay, this is one of those amps that's not idiot proof. You can make this thing go into oscillation and squeal and all kinds of stuff, and I chose this on purpose because I want you to have the flexibility. If you crank this thing all the way up, it's so hot rodded, you're going to go into squeal and oscillation. But if you back off a little bit and you're smart about it, you can crank up your post. Okay, so that concludes our presentation on this Precision Electronics Grommes, whatever model this thing is. But just to reiterate, this thing is not idiot-proof. It is not dummy-proof. It has a 12AX7 in the V1 position, and with that 12AX7, this thing has more gain than it can handle. So you actually have to, if you're going to turn up the post, okay, you have to back off on the pre to compensate. And this is just the way you're going to have to get used to using this amplifier if you use a 12AX7 and V1. And also, the switch on the back is a... I made that into a negative feedback switch, so you can switch it between two different types of negative feedback. And in one position, actually you can also put it in the middle where there's no negative feedback, but I don't recommend that at all. You have to have at least one or the other, really, for this thing to be stable. But with a 12AU7, and if this is in the position with more negative feedback, this thing is pretty much stable to the point where you can crank everything, and there's no issues like that. But with a 12AX7, which is how I would recommend running this, you can get really, really greasy kind of overdrive tones. And you can push it right up to the edge of just being too much. And it's up to you to find where that edge is for the sound that you're going for. So yeah, two totally different ways you can run this thing with the 12AX7 or the 12AU7 up front. You could also put a 12AT or any number of the other 12AX or A families of tubes, and it's going to give you a different response. If you want a cleaner amp, use the 12AU7. If you want more overdrive, then use the 12AX. But yeah, that's pretty much it. Thanks you guys for watching. If you haven't already done so, hit the subscribe button down below. And for now, you all take care.